Hey everyone, welcome back to my channel. In this tutorial, I'm going to demonstrate how to produce descriptive statistics, which is immensely important, not just for calculating the basic stats for reporting in a journal article, for example, but also it's hugely important for exploring how your data looks like. So it could be part of your exploratory data analysis. So now I'm gonna load my data to Stata. So I'm gonna use the web data. So that's somewhere online, and this is the name of the data set, and this is the code web use. And I'm gonna run the execute selection command here. Instead of using the command window, I'm using the do file editor, which is the kind of more advanced and organized way of doing things. Okay, so as you can see, my data is loaded, so there's a lot of variables, and I'm not going to work on all of them. So I'm going to just look at the data using the codebook commands that I have showed you before. So run the command, and you can see a summarized view of all your variables and their levels. So basically, and you can also similarly use a command called describe, and describe gives you the variable levels and all these information about the variables, but you can ask for a specific variable as well up to describe and use the name of the variables, and then it gives you the information about that variable specifically. So now let's make it simple, and let's go directly dive into descriptive statistics, for which you need to just use a command called summarize, or you can also, in short, you can write sum. Okay, does the thing for you. So I have used quite a number of variables, but you can use only one variable. Okay, so I'm using all of them variable, and then I'm selecting it and run the command. So after running the command, as you can see, this is the results for descriptive statistics. And then as you can see, these are the name of the variables, the numbers of observations, mean, so which is the arithmetic mean, standard deviation, which is basically says how spread out your values of these particular variables are. Like this is the mean, and if you add this number with the 23, and then also subtract 130 like 23 from 130, so like from then it is like 108 to 154. That means your majority of the variable like values, most of the values of BPC's total, this variable lie in the range between 108 and 154. Okay, so that's the standard deviation. It measures like the variability of this, or the spread out of your values of a particular variable. And then minimum value. At least one of the respondents has reported that they have systolic blood pressure of 65. So that is too low, and this is too high. This is the maximum value in your data set for this variable. I hope this was clear to you. And then let's go to use another command called this is gonna be the detailed descriptive statistics. This gives you some statistics, and then we're gonna use summarize command, and then we are adding an option called detail. Okay, so this gives you additional stats. Okay. So for each of the variables, for systolic blood pressure, for example, it gives you the percentiles. It gives you observations, mean, standard deviation, variance, skewness, and kurtosis. So this skewness is basically a measure of how skewed the distribution of your data is. Okay. Another way of understanding is that when your median, which is 15 percentile, 128, that is lower than 130, slightly lower than 130. So that means your data is rightly skewed. Okay. So that's what exactly it says. Skewness is 1. Skewness can be negative as well if it is left skewed, but we can see this right skewed. Okay, skewed to the right. So skewness 1 is kind of rightly skewed, but it's not not crazy number. It's not like hugely skewed to the right. So my professor used to use one as a cutoff. So when he sees the skewness as one, he because a lot of statistical assumptions require you to do like a normal distribution of your variable. So he does like log transformation or other kind of transformation if it is greater than one. Okay. It's a rule of thumb. It's not a science or something, but there's a lot of rule of thumbs and rules of thumbs in statistics, especially in applied statistics. Okay, so let's keep things short, and then kurtosis. Kurtosis is basically the tails, like how normal your distribution is, whether it has a tail, a right tail or left tail, or like how big of a tail it is. So three kurtosis of three is considered normal, but anything above three or below three is not normal. So 4.87 is shows that there's a big tail. Okay, and then percentiles, as you know that. So let's say, for example, 75th percentile. So that means that less than 75% of the people have 142 systolic blood pressure. So that's what it means. Okay. So this is the descriptive statistics, and then let's go to there are many commands, but I'm going to use the group difference command. So tabstat. If you use tabstat command, you can know the group difference. So I'm going to understand the difference between the difference of systolic blood pressure by diabetic and non-diabetic. Okay, the variable name is diabetic. So use tabstat command, and then the variable, you can use just one variable instead of all four, and then comma by. So and by, and then bracket diabetes. This is the group variable. Okay, and bracket, and then you can ask for a specific stats. If you don't ask for a specific, it's going to give you only the mean. Okay, so you are asking for stats, bracket, mean, standard deviation, SD, minimum, maximum, median, and bracket end. Okay, so start with tabstat, and then the variable that you want to know about by comma by the group variable, which is diabetes. Okay, and that group is between diabetes and non-diabetes. Okay, so select this variable and run the command, and now you see so it's in order. Okay, so mean so for non-diabetic, systolic blood pressure is 130, and then the number below is the standard deviation, and then minimum, and then maximum, and then P50 basically is percentile, 50th percentile, which is median. Okay, and then diabetic. So you can see a significant difference between. We can't say it's significant difference until we do the significance test or hypothesis testing, but we can see the difference might be significant because it's 130 for non-diabetic and 146 for diabetic, which makes sense because diabetes is a risk factor of high blood pressure, right? So therefore, people with diabetes has noticeably higher levels of systolic blood pressure. Okay, so yeah, so for understanding the group difference, use the command tabstat, and then the variable, and then comma by the group variable. Okay, so I think that's all for this demonstration. Thanks for watching. If you find this helpful, please don't forget to subscribe to the channel, and also like, share if you can. Thanks for watching again.